Hello and welcome to my EDEXCEL GCSE Maths Higher Paper 1 prediction paper for this summer. Before we begin, some general information. Firstly, I'd highly recommend that you download and try doing this paper before watching the walkthrough. I've put a link in the description so you can download it to try first. The paper perfectly covers the advanced topic list material released by AQA in February 2022. All of the questions are original and created by myself, so you won't find these questions in any other paper. And finally, there's no guarantee that questions will be asked exactly in this way, but this is excellent practice for your summer exams. For this question, we're going to draw a prime factor tree. So start with 126, and then think of two numbers that multiply to make this. I've gone for 2 times 63. 2 is a prime number, so we put it in a circle, and then we carry on with 63. What two numbers multiply to make this? I've gone for 9 times 7. 7's prime, so we put that in a circle, and then finally 9 can be split into 3 times 3, and 3 is prime, so we'll circle both of the 3's. So 126 is equal to all of the numbers in circles multiplied together, so 2 times 3 times 3 times 7. And the two 3's in the middle could be grouped together as 3 squared, so the answer is 2 times 3 squared times 7. In this question, we have an inequality to solve. To start solving this, I would add 3p to both sides. So if you put the less than sign in the middle, on the left hand side 9p add 3p makes 12p, and on the right hand side the plus 3p will cancel with the negative 3p, so we'll just be left with 48. The next thing to do is divide by 12 on both sides. If we divide 12 on the left, we get p, and if we divide 12 on the right, we get 4. So the answer to this question is p is less than 4. In this question we have a number in standard form and we need to write it as an ordinary number. So start with 6.25 and then the power is 10 to the power negative 3. This means divide our number by 1000 or move the digits 3 places to the right. So let's move 1 place, a second place, and a third place. So we end up with 0.00625. In this next part we have to do a calculation but give our answer in standard form. I'd start by multiplying the 7 and the 4. This gives you 28. We can then turn our attention to the powers of 10, so we have 10 to the 12 times 10 to the 3. In this case you would add the powers, so 12 add 3 is 15. So this is the same as timesing by 10 to the 15. This number isn't in standard form though. We need to make sure the first number is between 1 and 10. So if we divide the first number by 10, we'll get 2.8. But if we're going to keep this number the same, we also need to multiply it by 10 to keep things balanced. So if we multiply by 10 on here, we get an extra power of 10, so it's now 10 to the 16. This is now the same number, but written in standard form. In this question we have Helen and Emma, who are sharing money in the ratio 2 to 5. In the question we're told that Emma receives £21 more than Helen. This represents the difference in the amounts they receive, so we'll create an extra column for difference. The difference in the amount of ratio parts is 3, since 5 take away 2 is 3, so these 3 parts must represent the £21. To get from 3 to 21 you times by 7, so we'll times by 7 for all of the values. 2 times 7 is £14, and 5 times 7 is £35. In the question we're asked how much money Emma receives, so this must be £35. To work out 4/3 of 24, we first of all divide by the bottom number, so 24 divided by 3, which gives you 8, and then multiply by the top number, so 8 times 4 is 32. To add together these mixed numbers, I'd first of all add together the integer parts, so 4 add 3 gives 7. We can then add together the fractions, so 2/3 add 1/4. To do this, we're looking for a lowest common multiple for our denominator. The lowest common multiple of 3 and 4 is 12. We then convert the 2/3 and quarter into twelfths. So to get from 3 to 12 we times by 4, so if we times the 2 on the top by 4 we get 8. If we look at 1/4 now, to get from 4 to 12 you times by 3, so times 3 on the top, 1 times 3 is 3. We can now add these together, so if you add the numerators 8 add 3 gives you 11, and you keep the denominator as 12. If you combine both parts together here then, the answer is 7 and 11 over 12. In this question, we're trying to find the density of the cube. You should know the formula density equals mass divided by volume. In the question, we're told the mass of the cube, that's 16 grams, so we just need to find out the volume. Since it's a cube, the volume is just 4 times 4 times 4 again. This gives you 64 centimeters cubed. So now we have the mass and the volume, we can use the density formula. Mass divided by volume, so 16 divided by 64. If you simplify this down, you'll end up with 1/4, which is the same as 0.25. So the answer is 0.25 grams per centimeter cubed. In this question, notice how the equation of the graph matches the equation we're trying to solve, x squared plus 2x minus 1. Whenever you have a graph like this and the corresponding equation equal to 0, you're just looking for where the graph crosses the x-axis. There are 2 points for this marked here. The first of them is at negative 2.4, and the next one's at positive 0.4. For this question, we need to know how many degrees there are in a pentagon. To do this, we'll use the formula n take away 2 times 180. N is the number of sides, so this has 5 sides, so we do 5 take away 2 times 180. This gives you 540 degrees. This means all of the angles in this shape must add up to 540 degrees. Now we're told in the question that angle ABC is 4 times angle BCD. So if we call angle BCD x, then angle ABC is 4 times that, so 4x. We're also told in the question that this pentagon has one line of symmetry, so that would be down the middle here. This would mean that angle CDE is also 4x. Now that we have all of the angles labelled, we can add them all up. So if we start with x, add 4x, add another 4x, add 90, and add another 90. All of this must add up to 540 degrees. We can simplify this a little bit. If we collect the x's, we get 9x, and then the numbers, we get plus 180, and this equals 540. So now we have an equation to solve. First of all, take away 180 from both sides. On the left side, this will give 9x, and on the right side, 540 take 180 gives you 360. Now divide both sides by 9. On the left, this gives you x, and on the right, 360 divided by 9 gives you 40. The angle we were asked for in the question is BCD, which is labelled x in the diagram, so we've now found it. It's 40 degrees. The value of tan 60 is square root 3. For the next part of this question, we're going to use trigonometry. So label the triangle first, x is the hypotenuse, and 0.8 here is the adjacent, which means if we look at SOHCAHTOA, we're going to need to use cos. So let's write out the cos ratio. Cos of 60 equals the adjacent, which is 0.8, divided by hypotenuse, which is x. We are told in the question though that cos 60 is a half, so if we replace the cos 60 with a half, we have an equation to solve. If you multiply both sides by 2, that will clear up the half. 2 times 1/2 is just 1. If you times the right hand side by 2, you get 1.6 divided by x. If you now times both sides by x, you'll get x on the left, and the x on the right will cancel, so it's 1.6. So x equals 1.6. In this question, we'll first of all write down the ratio a to b. We're told that a is 25% of b, which means the ratio would be 25 to 100. We're also told that b is 30% of c, so for the ratio b to c, it would be 30 to 100. Now both of these ratios simplify. If you divide the top one by 25, you'll get 1 to 4, and if you divide the bottom one by 10, you get 3 to 10. To write these as a combined ratio a to b to c, we need to match up the thing that's common to both, which is b. In the top ratio, b represents 4 parts, and in the bottom ratio, it represents 3 parts. So if we can make these numbers match, we can join up the ratios. If you times the top ratio by 3 now, you'll get 3 to 12, and if you times the bottom ratio by 4, you'll get 12 to 40. So now the b is represented by 12 in both ratios. So the ratio of a to b is 3 to 12, but the ratio of b to c is 12 to 40, so we can just put a 40 on the end here. To draw a cumulative frequency diagram, we plot the endpoint of each group marked here with the cumulative frequency. So the first one would go at 20 with a cumulative frequency of 5. That's here. The next one at 30 and 22. That's here. Then 40 with 52. Here. 50 with 70. and finally 60 with 80. Now that you've plotted all of the points, you're ready to join them up. However, you must be careful where you join the first one. You'll see the lowest time we had here was 10 minutes, so we'll connect the first group from 10 to 20 minutes, not 0. So you end up with a cumulative frequency graph that looks like this. You may also draw your graph as a smooth curve if you prefer. For part B, we need to find the interquartile range. We were told there were 80 people in the question, so the lower quartile will be at 20. So go from 20 across, and then down, and read off this value. The upper quartile would be at 60, so go across, and down, and read off this value. For the upper quartile, I get 44, and the lower quartile, I get 29. 44 take 29 is 15. In this question, we're told the probability that both counters are green is 9 over 25. Imagine we didn't know this, and we were trying to find the probability that both were green. We'd write probability of green followed by green, and then do the probability of green on the first go, and times that by green on the second go. And we know this gives 9 over 25. Because of the way the question's asked, we know that the probability of getting a green on the first go is the same as green on the second go. This is because the counter is returned to the bag. So both of these fractions here must be the same. To get a 9 on the top, we must times 3 by 3, and to get 25 on the bottom, we must times 5 by 5. So the probability of getting a green is 3/5. In the question, we're told that the counters are only green or blue. This means the rest must be blue, so 2/5 of blue. If we're now asked to find the probability neither of the counters is green, they must both be blue. So we're trying to find the probability of blue followed by blue, which is 2/5 times 2/5, which gives you 4 over 25. And that's the answer to the question. To start this question, we want to find the total mass of all of the animals. The mean mass of all of the animals is 10 kilograms, and we're told there are 20 cats and 30 dogs, so there's 50 animals altogether. So if we do the mean mass 10 times the total animals 50, we get a total mass of 500 kilograms. Now let's look at the total mass of all of the cats. The mean mass for cats was 4 kilograms, and there are 20 of them, so 20 times 4 gives a total mass of 80 kilograms. We can now work out the total mass of all of the dogs. That's the total mass of all of the animals, take away the total mass of the cats. So 500 take away 80, which gives you 420. We can now finally finish the question. We're asked for the mean mass of the dogs, which is the total mass, 420, divided by the number of dogs, which is 30. 420 divided by 30 gives you 14 kilograms. In this question, we need to paint the walls of a sports hall. Let's start with the front wall and the back wall. Both of these are rectangles with dimensions 30 by 8, so if we do 30 times 8, but times 2 since there's 2 of them, we get this red area, which is 480. Now let's look at the side walls. These are both rectangles again, 20 by 8 this time, and again there's 2 of them, so 20 times 8 times 2 gives you 320. If we add this together, we get 800 meters squared, which is the total area we need to paint. We're told in the question that each of the tins will cover 75 square meters, so we need to see how many times 75 goes into 800. This is quite tricky for a non-calculator question. Instead, let's just count up in 75s. In fact, 75 times 10 is 750, so 10 tins is nearly enough. If we add another tin and do 75 times 11, we get 825, so now we do have enough, so we'll need to buy 11 tins. For this question, we'll start by expanding the first two brackets, so 2x plus 3 times x minus 1. We'll do this using FOIL. So 2x times x is 2x squared. 2x times negative 1, negative 2x. 3 times x is plus 3x. And 3 times negative 1 is negative 3. This will simplify a little bit. We can collect the x terms here, so we end up with 2x squared plus x minus 3. Since this is the result of the first two brackets, we can times this by the final bracket. So take your answer from the first part and times it by x minus 3. This will give us 6 multiplications to do. So we'll start by timesing 2x squared by x, which is 2x cubed, and then 2x squared by negative 3, which is negative 6x squared. We then move on to the x term in the first bracket. So x times x is plus x squared, and x times negative 3, negative 3x. And then we move on to the final term in the first bracket, negative 3 times x, negative 3x, and negative 3 times negative 3 is plus 9. We have some simplifying to do here. There's only one term with x cubed, so 2x cubed. For the x squareds, we have negative 6x squared add x squared, which gives you negative 5x squared. Negative 3x take away negative 3x is negative 6x, and then there's a plus 9 at the end. To simplify this question, we need to factorise both top and bottom. The top is a bit tricky, but the bottom is much easier. You should spot this is the difference of two squares. X squared minus 36 would factorise as x plus 6, x minus 6. When you look to factorise the top, you're going to expect one of the brackets from the bottom to appear again. If you look at this final term here, plus 42, this suggests that both of the brackets contain a plus sign, or they both contain a negative sign. Since it's negative 19x, they will both contain a negative sign, which means we're expecting x minus 6 to also be on the top. Now to work out the other bracket. Since we need to times x by something to get to x squared, we can expect the other bracket to contain 2x, and since we need to get a plus 42 at the end, and we've already got a negative 6, you'd expect a negative 7. So it turns out it's 2x minus 7. If you ever want to check this, you can just expand it to make sure it works. We can now cancel out the common factors on both top and bottom, and we're left with our answer, 2x minus 7 over x plus 6. The first thing I'm going to do in this question is remove the negative on the power by taking the reciprocal of 8. So instead of writing this as 8 to the negative 4 over 3, I could write it as 1 over 8 to the power 4 over 3. When we then look at this fractional power, the 3 on the bottom means we need to cube root, and the 4 on the top means we need to do it to the power 4. So instead, we'll write this as the cube root of 8 to the power 4. The cube root of 8 is just 2, since 2 times 2 times 2 is 8. So this is 1 over 2 to the 4, and 2 to the 4 is 16, since 2 times 2 times 2 times 2 again gives you 16. So the answer to the question is 1 over 16. For this question, we need to do some simplifying of surds. I'll start with this square root 27 here. Square root 27 can be written as square root 9 times square root 3. But square root 9 is equal to 3, so this is just 3 root 3. So we can replace square root 27 with 3 root 3. We can now try and rationalise the bottom. There's a surd here, but we don't want a surd there in the answer. So we'll times both top and bottom of this fraction by 2 root 3 minus 1. Notice this is the same as the bottom, I've just changed the sign. Let's multiply the numerators first. Think of these like you expand brackets. So let's do 3 root 3 times 2 root 3. 3 times 2 is 6, and root 3 times itself is 3, so 6 times 3 gives you 18. Now let's do 3 root 3 times negative 1, which is negative 3 root 3. And then 2 times 2 root 3, which is plus 4 root 3. And then 2 times negative 1, which is negative 2. We'll take the same approach on the bottom. 2 root 3 times 2 root 3. 2 times 2 is 4, and root 3 times itself is 3. 4 times 3, 12. We then do 2 root 3 times negative 1, which is negative 2 root 3, and then 1 times 2 root 3, which is plus 2 root 3, and 1 times negative 1 is negative 1. We can simplify both top and bottom here, so let's start with the top. 18 take away 2 gives you 16, and negative 3 root 3 plus 4 root 3 is just plus 1 root 3. On the bottom, 12 take away 1 gives you 11, and negative 2 root 3 add 2 root 3 just cancels out. So we're left with 16 plus root 3 over 11, which matches the form we want in the question. For this question, start by writing x equals 0.47 recurring, but in its full decimal form. Then times by 10 to get 10x, which is 4.7 recurring. At this point, some people may choose to subtract, but I like to only subtract when all of the digits after the decimal point line up. You'll see here we have a 4 and 7 that don't match. So I times by 10 again to get 100x, which is 47.7 recurring. If you look at the top two of these now, you'll see everything after the decimal point does line up, they're all 7s. So I take away these two. 100x, take away 10x. 100x take away 10x gives you 90x. Then we have equals. and then on the right hand side of the equals, 47 take away 4 gives you 43, and all of the other 7's cancel to give you zeros. So we end up with 90x equals 43. If you divide both sides by 90 here, you'll get x on the left, and then 43 over 90 on the right. And that's your answer to the question. In this question, we're told the ratio of males to females is 3 to 5. Since there are 8 parts here altogether, and 3 parts are males, then 3/8 of the class are males. In a similar way, 5/8 of the class are females. We're interested in only those that chose science. If we look at this next statement, the ratio of males who chose English to males who chose science, we find the ratio of that is 3 to 1. Since the second part of this ratio is science, then 1 out of 4, or a quarter of those, chose science. So a quarter of males chose science. If we look at the same idea with females, the ratio of females who chose English to females who chose science is 2 to 3. The second part of that is those that chose science, so that's 3 out of a total parts 5, so 3/5 of females chose science. If we now go back to the males, 3/8 of the class are males, and a quarter of those males chose science. So if we do a quarter of 3/8, which means times 3/8, we get 3 out of 32, which represents the fraction of males in the class that also chose science. If we do the same idea with females, 5/8 of the class are females, but 3/5 of the females chose science. So 3/5 of 5/8 gives you 15 over 40, which simplifies to 3/8. So 3/8 of the class are females that also chose science. So we now have 2 fractions of the class which chose science. We have 3 over 32 and 3 over 8. So all we need to do is add these together. We'll go for a common denominator of 32, so leave the first fraction, and change the second fraction to something over 32. To get from 8 to 32 we times by 4, so times 4 on the top gives you 3 times 4, which is 12. You can then add numerators, 3 add 12 gives you 15, so the answer to the question is 15 over 32. In this question we're trying to calculate the gradient of the graph when t equals 20. To do this, we draw a tangent to the curve at t equals 20, something like this. We then need to work out the gradient of this tangent. To do that, you need to draw a gradient triangle. I'm drawing mine here. I then need to work out the change in y and the change in x. The change in y goes from 80 to 50, so 80 take away 50 is 30. The change in x goes from 0 to 40, so 40 take 0 is 40. I then do change in y divided by change in x, so 30 over 40, which is the same as 3 over 4, or 0.75. Now you may not have drawn your tangent exactly in the same way as I have. As long as you use this method here and get a number near to mine, you'll be okay. In this last part, we need to explain why Michael is wrong. We're looking at the acceleration at t equals 20 and t equals 15. We've already drawn a tangent for t equals 20, so let's draw one for t equals 15 as well. The acceleration is represented on the graph by the gradient. Since the tangent is steeper at t equals 15, we know the gradient is higher, which also means the acceleration is higher. So the acceleration is the gradient of the graph. Since it's steeper at t equals 15, it's accelerating faster. We're told here that t is directly proportional to m squared. This means we can write t equals km squared, where k is a number we need to find. We're also told that when t is 2, m is 4, so we can substitute those numbers in. So t is 2, so 2 equals k times m squared, but m is 4, so 4 squared. If we then write this out again, 2 equals 4 squared is 16, and k times 16 is 16k. If we divide both sides by 16, we get k equals 2 over 16, which simplifies to 1 over 8. So now we found k, we can write the formula out again, t equals km squared, but replace k with an eighth, so t equals 1/8 m squared. Now let's look at m is inversely proportional to square root r. This means m equals k over square root r, and we're told m is 2 when r is 9. So if we substitute those in, we get m is 2, so 2 equals k over square root r, but r is 9, so it's square root 9. But you know square root 9 is just equal to 3. If you times both sides by 3 here, you'll get k equals 6. So this formula is m equals k over square root r, but k is 6, so it's m equals 6 over square root r. We were asked to find a formula for t in terms of r. If you look at this first one here, we have t in terms of m. So we could write this out, but change the m using the second formula. We could substitute m for 6 over square root r. So we'd write t equals 1/8, and it's then m squared, but instead of m, we're going to write 6 over square root r. So 6 over square root r squared. We can then simplify this, so t equals 1/8 times. Squaring this gives you 6 times 6, 36, and squaring the bottom, square root r times square root r, just gives you r. We can cancel here by dividing through by 4, giving 9 over 2. So the answer is t equals 9 over 2r. In this question, we're told the length AB is square root 72. Since this is a sector, then OB and OA are both radii. So we have a right angle triangle here. If we do Pythagoras on this, then r squared plus r squared equals square root 72 squared. If we simplify the left hand side, we've got 2r squared, and on the right hand side, the square root of 72 squared is just 72. We can now divide by 2 on both sides, giving r squared equals 36, and then square root both sides, giving you r equals 6. Of course, you could have negative 6, but we can't have a negative length. This tells us the radius of the sector is 6. We can now work out the area of the sector. So if we do pi times r squared, which is pi times 6 squared, that would be a whole circle, but since it's a quarter circle, we can divide that by 4. So pi times 6 squared is 36 pi, divide by 4, 36 pi divided 4 is 9 pi. If we now work out the area of the white triangle, this would be half times the base, which is 6, times the perpendicular height, which is also 6, and this gives you 18. So the shaded area is the area of the sector, 9 pi, take away the area of the triangle, 18. So the answer to the question is 9 pi take away 18. The first thing to do in this question is label on the vectors PS, which is A, and PQ, which is B. We're told that XY and PM are parallel, so let's draw those on as well. We can write an expression for PM very easily, it's just A plus half B. But XY is a little bit harder. To get from X to Y, we'd probably go from X to Q, and then Q to Y. So let's look at this in more detail. In particular, the QY bit first. The vector QR, which I've marked on in green, is A. Because it's a parallelogram, it must be the same as the one at the bottom. We also know that the point Y splits this line into the ratio 2 to 3. So QY is 2/5 of A. Now we're told in the question that XY and PM are parallel. This means if you take PM and times it by some number, you must be able to get XY. We know what PM is, it's A plus half B, so we can write that in, times some number n must give you XY, and at the moment XY for us is this, which is XQ plus 2/5 A. If we multiply the bracket on the left hand side, we get NA plus half NB, and then keep the right hand side the same. These two must be equal for some number n. The vector XQ here is parallel to this vector, so it must be a multiple of B. This means the only terms involving A must be the NA here and the 2/5 A here. Therefore we can conclude that n must be 2/5. If we now look at these two terms, knowing that n is 2/5, we get 1/2 times n, which is 2/5, times b, must equal xq. If we multiply 1/2 and 2/5, we get 2/10, which simplifies to 1/5. So xq must be 1/5 b. We can mark that on the diagram. If xq is 1/5 b, then px must be 4/5 b, since the whole vector pq was b. We can now write the ratio px to xq. It must be 4/5 to 1/5. If you then times this ratio by 5, you'll get 4 to 1, which means k must be 4. To start this question, we'll draw on the line OA and then use a gradient triangle to work out its gradient. The change in y is 8 and the change in x is 6. This means the gradient of OA is 8 over 6, which simplifies to 4 over 3. The gradient of the tangent would be the negative reciprocal of this, since the tangent meets the radius at 90 degrees. so the gradient of the tangent is -3/4. We can now write out the general equation of a line y equals mx plus c. If we substitute m for -3/4 since we know that's the gradient, we now need to work out the value of c. To do this, you need to know a point on the line. We do know a point on the line A, which is 6, 8. So if we substitute in 6 for x and 8 for y, we end up with 8 equals -3/4 times 6 plus c. If we simplify this a little bit, -3/4 times 6 is -18/4, which simplifies to -9/2, and plus c. We can rearrange this to get c equals 8 plus 9/2. If we convert the 8 to 16/2, we can add these together to get 25/2. Now you have your c value, you can write out the equation of the line. It's y equals -3/4x plus 25/2. We want to find out the value of p though. P is where the tangent meets the x-axis, or where the y-coordinate is 0. So let's set y equals 0 in the equation. So 0 equals -3/4x plus 25/2. If we add 3/4x to both sides, we get 3/4x equals 25/2. We can then solve this equation by timesing by 4 and dividing by 3 on both sides. That would give you x equals, timesing by 4 gives 100, and dividing by 3 gives 6. If you divide both of these by 2, you'll get 50/3. So the x-coordinate of that point B is 50/3, and of course the x-coordinate was p. So we've now found p, 50/3. Thank you for watching this video. I've put some rough grade boundaries here so you can see how well you've got on. Of course, we won't know the real grade boundaries until after the real exams are done, so take these with a pinch of salt. Also, check out what I think you should watch next and subscribe so you don't miss out on future uploads.